All right, welcome back to our lecture video series on food and drugs. This is the very last lecture video of the semester, so congratulations to you for making it all this way. I hope that you realize just how far you've come, and I hope that this final video is something interesting and a little bit fun. Okay, so what is organic chemistry really all about? Well, it's about these guys. Okay, bear with me for just a sec. Okay, so we've got these two molecules all the way to the left. The top one is testosterone. The bottom one is estradiol. Then in the middle, we've got ibuprofen, and we've also got delta-9 THC, which is the psychotropic cannabinol that's in pot. And then we've got vinyl chloride, which is a monomer that you can react with a bunch of other iterations of itself in order to make polyvinyl chloride, which is the main component in records, in like vinyl records. Are you seeing the pattern? If you don't, all the way to the left, we have sex hormones. In the middle, we've got some drugs that you can take, and then all the way to the right is the vinyl that composes rock and roll records. So organic chemistry is all about sex, drugs, and rock and roll. Isn't that cute? Thanks, Dr. Nichols. Okay, let's get into our discussion of drugs right there in the middle. So these were some of the 10 popular prescription drugs in 2018. Okay, so these are the first 1, 2, 3, 4, 5 of them. You notice that I actually skipped number 5 and I went right up to number 6. Really, all that I'm trying to show you here is that prescription drugs are really creative with their structures, okay? And so there are all of these different ways that you can branch hydrocarbons off of each other. You can have multiple cyclic portions. You can have a bunch of carboxylic acids. You can have some amine groups. You can have some ethers. You can have some iodides. What I do want to start highlighting in our discussion of drugs is number 6, Prilosec, is pretty similar to Prevacid, which is another commonly prescribed drug for gastrointestinal esophageal reflux disorder, okay? I want to highlight these two because notice that they're really similar in their 3D structure. And then some of the differences are that, well, Prevacid is missing that little methyl ether bit over there. And then Prevacid has this extra like trifluoral sort of thing going on. But they're pretty close, which kind of suggests to me that they might almost get the same job done, right? Which kind of makes sense then that they're both prescribed for GERD, okay? Now, do all drugs that treat the same thing, do they all end up looking the same? Not necessarily, but often we can start to see this theme that they almost always do have similar 3D structures. Here are some other ones. Vicodin is commonly prescribed, and now it's prescribed, right? You've also got gabapentin, which is an epilepsy medicine. You've got albuterol. I've had to take albuterol since I was a child because I've had asthma. We've got Zoloft for depression. We're going to talk a little bit about serotonin and dopamine in a few slides. And then you've got amoxicillin, which is one of the most commonly prescribed antibiotics. Okay, I really like looking at the structure of amoxicillin because there's this really uncommon four-membered ring. Four-membered rings are really unstable. They're really reactive, and they will probably mess up a bacteria cell pretty bad. So it's kind of interesting. So again, just trying to show you that these prescription drugs are really interesting to look at, and so then synthesizing them is also a pretty hefty task that a lot of organic chemists tend to take on as like their life's work is just organic synthesis. Let's talk real quick about birth control pills. These are probably a little bit more commonly prescribed. It may be one of the more common prescriptions that you might see, at least among those who would benefit from taking birth control pills. So on the left, you actually have Orthonovim, and Orthonovim is a mixture of norethindrone and ethinyl estradiol. Okay, and so what I notice about Orthonovim is that the norethindrone is really, really similar in structure to progesterone, and ethinyl estradiol is really similar in structure to estrogen. Okay, and so progesterone and estrogen are actually the body's, well, an XX chromosome holding person's body's sex hormones. Yeah, and depending on where a person might be in their menstrual cycle or their phase of life, they might have some elevated levels of progesterone or estrogen, okay? And it kind of helps the body decide when it's time to menstruate or when it's not time to menstruate. And also, what's interesting about progesterone and estrogen is that if you become pregnant, your body way elevates its levels of progesterone all by itself, and this causes the uterus to basically close up, not accept any more things into it because it's trying to grow a baby. It also makes the ovaries stop ovulating, right? Because it's already got a baby in there. And so basically what we are doing when we take birth control pills is we are taking these guys, which is tricking our bodies into thinking that we are already pregnant. And so therefore it's not necessary to ovulate, and it also causes the cervix to make some more mucus and close itself up more tightly, which makes it harder for additional sperm or really additional pathogens to get up inside of the uterus. All right, so it's kind of interesting that we're using chemistry to trick our bodies into something. Yeah. And again, we're doing it because we make these molecules that look almost exactly like the molecules that our body naturally makes in certain situations. We see similar things with alkaloids, okay? So alkaloids are naturally occurring nitrogen-containing compounds found in plants. These guys are the alkaloids that I'm talking about, okay? But these ones down here, these are serotonin and dopamine, okay? So serotonin is a neurotransmitter molecule that is important not in depression. It's more like it's important in avoiding depression. If you have depression, then chemically what's often going on in your body is you either don't have enough serotonin or your body is snatching back up the serotonin that you're making or something like this. You have low amounts of serotonin on an ongoing basis. Dopamine is more involved in that feeling of like the reward system in the body. Dopamine is more like the rush that you get when you get an A on a paper, or when you win a game, or you really nail that leap if you're a dancer, or video games, like you get a dopamine rush. Okay, so it's a bit more of that like instant gratification sort of feeling. Serotonin is more like your longer term mood that lasts hours at a time or weeks at a time. Okay. So now what's going on with these alkaloids? These are chemicals that can be found in plants that might mimic serotonin and dopamine that could occur naturally in our bodies, but we can also kind of mimic with these plants. So this first one at the top is nicotine, which is of course the main component in cigarettes and tobacco leaves, but also these days in e-cigarettes. And you can see that nicotine has a fairly similar structure to both serotonin and dopamine, just a little bit, which is kind of interesting to me. Next one that is my personal favorite is, of course, caffeine. And this is a very obvious analog to serotonin. And so, it kind of makes sense that caffeine might falsely elevate your serotonin levels in order to trick your brain into thinking that you have more energy than you actually do. Another one is theobromine. This one is one that most people haven't heard of, but theobromine is commonly found in chocolate, and it has effects that are very similar to caffeine, but it's not as intense, and you can see that it has a very, very similar structure to caffeine. And again, it kind of does that same effect with our serotonin levels and a little bit with our dopamine levels as well. The last one here is cocaine. And so you might notice that there's like these weird lines over here. That's because, okay, so remember, molecules exist in 3D space. So really what's going on is that you've got this base ring here at the bottom that's kind of making like a bridge. And then you've got like a top bridge, like an arbor or an archway over this little ring. Okay, but I would say that cocaine kind of mimics dopamine a bit, and that's exactly what it does. Is it is this analog for dopamine, and it tricks your body into thinking that it has more dopamine than it actually does. It's also relatively short-lived compared to some other drugs that you might see, and then I've heard that it does kind of mimic some of those dopamine sort of effects. Okay. Let's talk about illegal drugs. Okay, so every year, the United States runs the National Survey on Drug Use and Health. Okay, it's from the Center for Behavioral Health and Statistics and Quality. And so every year they like to see like what demographics of people use them, and they pair that information with like people's race, people's income, the types of jobs that they do, and their age and their gender, and all of this really information. And they also note as many of the drugs that they take and so on. And so these are all of the drugs that they include in their studies, okay? So here's just a little bit of the data from the 2019 survey. And I mean, as you might expect, like there's not a whole lot of drug use amongst really, really young people. And then drug use kind of starts increasing like a lot as soon as people get to about age 16 or 17. And then it skyrockets in early adulthood from 18 to 25. And then it starts tapering off between 26 to 49. I really wish that we could have some data between like the different age groups in the 26 to 29 bracket. And then you notice that in folks 50 years and up, it goes way, way down. And so again, that's the use of illegal drugs. I would hazard a guess that as we get older into this age group, then you start to use a lot more prescription drugs instead of illegal drugs. We're focusing on these recreational illegal drugs. So here are some popular illegal drugs. So of course, THC and cannabidiol are the two main components that we tend to hear discussion about in the use of marijuana and hash oil. Hash oil, these days, you tend to hear this called dabs. And so if you hear someone talking about dabs, they're talking about very, very high concentration of marijuana extracts, okay? Technically, THC is the drug that binds to your CB1 receptor and it leads to psychotropic effects. Cannabidiol, CBD, changes the shape of your CB1 receptor, but it doesn't bind to the active site, and so it supposedly does not cause psychotropic effects, and yet it does still have some action as like a pain reliever and things like that. And it helps modulate the effects of THC on the brain, supposedly. There's a ton of THC and CBD research going on in analytical labs right now, and so these claims are still under review, but this is the information that we currently have available, so this is what I'm sharing with you. So anyway, marijuana and hash and dabs tend to be used with the greatest proportion at about 35.4%, at least amongst 18 to 25-year-olds, okay? The next greatest use is MDMA, which comes in both ecstasy and Molly. Just depends on how you want to take it, but either way, you would be taking MDMA. It's the same active drug there. And then following close behind is LSD at 10%. Look at that thing. It's really big, isn't it? That's a really complicated structure. And then cocaine is the next greatest incidence one, and we already saw that earlier. Okay. What else do we have? So I wanted to talk a little bit more about THC and CBD. So I talked about this verbally a moment ago. So in the last lecture video, I talked about how proteins can be enzymes just a little bit. We talked about how things like sucrose and sucralose, they like sucralose tricks the body into thinking that it's ingesting something sweet, which it is. So what's going on is your enzymes are actually 3D shapes, okay? And so this could be an example of how the CB1 receptor could be shaped, but all enzymes have this 3D shape. And that 3D shape is accustomed to accepting some sort of molecule that fits into it, okay? And the site where that molecule binds to it is called its active site. So enzymes aren't ever perfectly shaped like this, with a circle, like a circle with a slice of it taken out. They're much more complicated structures, but this is still the idea behind it, is that you've got this protein structure and there's a very obvious spot for something to fit in there and lock in, okay? So like this is the lock, and then something with this general triangular shape would be the key. So in your CB1 receptor, THC is a key that fits really well into this lock. It's not the key that should fit into your CB1 receptor naturally, but it is a key that can fit in there pretty well. Now, CBD has a slightly different molecular structure and therefore a slightly different shape, and so it can also bind to the CB1 receptor, and then when it does so, it kind of blocks THC from binding in there, okay? But it does so without fully binding into the CB1 receptor and without doing the same thing as THC, and so in so doing, that's how it is said to like modulate or lessen the effects of THC. Okay, so that just gives you a little bit of a visual of what is going on there. Here are some other popular illegal drugs amongst 18 to 25-year-olds. And I just bring these up. I mean, we've got some variances with them. So what's interesting to me is that psilocybin is kind of an interesting one. And it does kind of look like serotonin again, and yet it's got all of these other things out on the fringes, and then it's got this phosphate group bound to it, which is really interesting to me. So again, it's kind of messing with our serotonin levels in some funky ways. Methamphetamine kind of looks a lot like dopamine, which is interesting. Okay. Heroin is another big one. It kind of ends up looking big. It ends up affecting your dopamine and serotonin levels. We're starting to see an increase in heroin use. The survey does differentiate between heroin that is smoked or snorted versus that which is injected, which is really interesting. There's also an uptick in the use of codeine. It's up to about 5.3%. This might be used in more like mixtures of drinks such as lean and or just taken by itself. Who knows? Who knows what people do? And then there's amyl nitrite, which isn't quite as popular in popular culture. I would say that the last pop culture figure that I've heard of doing this is Steve-O from Jackass. He tended to do a lot of amyl nitrate when he was on his benders, when he was still using. Now he's gotten clean. Take a look at heroin and codeine. Aren't they just super similar? It's probably not a shocker that they tend to work in similar ways as well. One of the most common questions that I get asked is if I know how to make methamphetamine just like on Breaking Bad, and technically I do. Would I ever do it? Nope, because it's pretty dangerous. But this is how you make it. So you start off with Sudafed, which, as you note, already has a pretty similar structure to methamphetamine. And basically what we're trying to do is we're trying to remove this hydroxyl group, but somehow leave the carbon group alone. And so just with some red phosphorus and then iodine, which when you mix these two together, they make HI anyway. And also with a little bit of heat, then yes, you can make methamphetamine, okay? So you can obtain Sudafed from cold medicines. You can get red phosphorus from matchbook striking strips. Iodine itself is not hard to get either. But of course, if you tend to purchase all of these things, then the government starts noting how much Sudafed you've purchased, and you basically get put on a list so that the feds will suspect that this is exactly what you're up to, is making methamphetamines. So I don't recommend that you do it. What you need to take away from this portion of the lecture is basically those alkaloids and a little bit of the illegal drugs as well, but also this big theme, this recurring theme, that many drugs that we use, both prescription drugs and illegal drugs, are similar in structure to the naturally occurring hormones or neurochemicals that they would be replacing or supplementing in our biological receptor proteins and our biological systems. Okay? So that's it. That's class. That's the end of this lecture series. Let me know if you have questions on homework 12 as we move forward towards the final exam. And again, thank you so much for a good semester, and take care.